Today we will continue to the advanced level questions of loops in Python. Number 1. Write a Python program to print the Fibonacci sequence up to n terms using a loop. Number 2. Write a Python program to check if a number is an Armstrong number. Number 3. Write a Python program to find the greatest common divisor of two numbers using a loop. Number 4. Write a Python program to print the first n rows of Pascal's triangle using nested loops. Number 5. Write a Python program to print a diamond-shaped star pattern for a given number of rows. First question. Let's write a Python program to generate the Fibonacci series up to n terms. First, we take input from the user to define how many terms we want. We start with two variables, a as 0 and b as 1, the first two terms of the Fibonacci sequence. Then we use a for loop that runs n times. In each iteration we print a, then update a and b as b and a plus b. This way, the series keeps building by adding the previous two numbers. For example, if n is 5, the output will be 0, 1, 1, 2, 3 inches. Second question. In this example, we'll write a Python program to check whether a number is an Armstrong number. An Armstrong number is a number that equals the sum of its own digits, each raised to the power of the number of digits. For example, 153 is an Armstrong number because 1 cubed plus 5 cubed plus 3 cubed equals 153. We start by taking input from the user and storing it in a variable called num. Then we calculate how many digits are in the number using len-stronum and store that as order. We make a copy of the number in a variable called temp and set a variable sum to 0. Using a while loop, we extract each digit from the number using temp modulo 10, raise it to the power of order, and add it to sum. We remove the last digit using temp equals 10 and repeat until all digits are processed. Finally, we compare the original number with the sum. If they're equal, it's an Armstrong number. Third question. Let's write a Python program to find the greatest common divisor, or GCD, of two numbers using a loop. We begin by asking the user to input two numbers. Let's call them a and b. Then we use a while loop that keeps running as long as b is not 0. Inside the loop, we repeatedly update a with the value of b and b with a %b. This method is known as the Euclidean algorithm. Once the loop ends, the value of a will be the greatest common divisor of the two numbers. It's a fast and efficient way to find the GCD using just a few lines of code. Fourth question. In this example, we'll print Pascal's triangle using nested loops in Python. Pascal's triangle is a triangular array where each number is the sum of the two numbers directly above it. We start by taking input from the user, the number of rows to print. Then we use a for loop that runs from 0 to n, where n is the number of rows. Inside this loop, we first print spaces to center align the triangle. Next, we use another loop to print the values in each row. We calculate each number using the combination formula, num equals num times open parenthesis, I minus j close parenthesis, divided by open parenthesis, j plus 1 close parenthesis. This gives us each element without using factorials. After printing all values for a row, we move to the next line. The result is a clean, pyramid-shaped Pascal's triangle built using nested loops. Fifth question. In this advanced Python example, we'll use loops to print a diamond-shaped star pattern. This is a classic problem to practice nested loops and pattern design. First, we ask the user to enter a number, say an, which determines the number of rows in the upper half of the diamond. We start with the upper half of the diamond. Using a for loop from 1 to n, we first print spaces to push the stars to the center. The number of spaces is n minus I. Then we print stars using 2 times I minus 1, which ensures that the stars increase symmetrically across rows. After finishing the upper half, we move on to the lower half using another for loop, this time from n-1 down to 1. Again, we print spaces and stars in the same way to mirror the top half and complete the diamond. The result is a neat and symmetrical diamond shape made completely using loops. This pattern is often asked in coding tests, and practicing it improves your control over nested loop logic and formatting output. And that's all for today. Let's end this video here, and I will meet you in next video.